Hi, everyone. Thanks for joining our session Onshape for student teams and competitions. My name's Domenico Damari. I'm also joined today by my coworker, Drew Bennett, and we're happy to be here talking about this. So we'll wait a second for people to come on in, but let's quickly get started. So today's agenda, we're going to talk about how Onshape fits into Teams usage. We also have a couple really cool team highlights that we want to cover. Following the highlights, we're going to go into a deep dive on two teams, one an FRC team and one an FSAE team. We're also then going to show two demos that we really got from these deep dives after talking with the teams, and we want to share them with you. We'll finish up with some key resources for teams, and then we'll have a Q&A. And as we go, if you have any questions, you should see on the right side of your screen a Q&A section. Feel free to throw those questions there, and we'll try to get to them at the end. We're going to try to leave about 10 to 15 minutes there for you. Cool. So let's get on into it. I'll introduce myself. As I said, my name's Domenico. I'm a applications engineer on our education team. So what that really means is I get to play with a lot of our tools and support the students and educators that are using them. And so a lot of the things I work around are those collegiate teams like FSAE. I develop enablement materials for them, and I also manage some of those collegiate team partnerships. My background is mechanical engineering. I'll turn it over to Drew to introduce himself.
Hey everyone, my name is Drew Bennett, and I'm an education solutions engineer here on the PTC education team. For a little bit about me, so I study mechanical engineering at the University of Maine, and for my experience, I'm a certified Onshape professional, and I've also been involved with competition robotics for over 10 years now, and I have a lot of experience designing both FIRST and VEX robots in Onshape. I'm also currently a FIRST mentor, shout out to teams 3467 and 6329. My role on the PTC education team is to work with our education partners and make sure that their audiences have all the enablement materials and technical support that they need to be successful.
Thanks, Drew. So let's get right into it. So using CAD and design for teams, I've been on teams, Drew's been on teams. We work with a lot of teams, and I'm sure hopefully a lot of you are also on teams. You go through this process every year of designing, manufacturing, and then going to competition. And I know I've had these challenges, and I'm sure you face them as well. During all of these steps, there's a lot of things that can go wrong, and CAD can get in your way and help you at the same time. And so one of the challenges I remember facing, and I bet you've seen, is just having to install CAD on everybody's devices. I know not everybody on the FSA and Baja team I was a part of had a Windows device. So it was really challenging to get them up and running with different tools. And then going to competition, I also distinctly remember trying to explain the decisions I made designing suspension and having to do it off of some different things that I'd printed off. I'd screen captured some things, some pictures of the suspension, a design I was going with, and a design I changed to. And trying to explain the differences was really hard when all I had were a couple of these screenshots. Onshape really can fit into this workflow and get rid of a lot of those challenges. I mean, I'm sure you already know Onshape can be used on a bunch of different devices, Chromebooks, MacBooks, iPads, iPhones. And so being able to seamlessly switch between devices, get everybody involved, has been really powerful for a lot of the teams that I've worked with. And if you're already using Onshape on your team, I'm sure you've seen it as well, especially with things like going into a design review. You don't have to worry about a student forgetting to bring their file on their flash drive. It's already up there, shared with you. So even if they forgot to bring it, maybe they're not able to come to the meeting, you're still able to review their work and decide whether or not it's an approach you want to take. So Onshape really fits into a lot of these teams. We've seen it, and it's really been great to see the success that the teams have had. And teams aren't the only ones having success. A lot of companies from small to large, they're making the switches for the same reasons that we really see the benefits for teams: the version control, the collaboration. All these different companies are making the switch, and you're really setting up your students or yourself for that successful career once you get out of college or high school, being able to go into the workforce ready with those skills is super important. And I just want to call out at the same time, we support a ton of different teams and competitions. Drew and myself, we work with a lot of individual teams, but we also work with competitions. We sponsor some of these larger competitions. We go to them. We really like interacting with all of the different teams from high school, middle school, college, grad students, anything in between, all across the world. It's really great to see that, the adoption that's occurring right now. So now I'm going to hand it over to Drew to talk through a couple of these team highlights.
Thanks, Dom. For those of you that heard Dave Katzman's keynote intro earlier, you heard him mention how Onshape is becoming the preferred CAD collaboration platform for student design teams, and he's absolutely right. Whether it be for things like robots, submersibles, cars, rockets, capstone projects, whatever you can think of, we're seeing massive movement towards Onshape. So let's take a quick look at some of these super successful student design teams that are using Onshape right now, and we'll check out how it's helping them succeed. So these slides will each highlight who a team is, an awesome model that they've made, their performance record, and some other information about them. So our first team here is one that's close to home for us, and that's FRC Team 6328, Mechanical Advantage out of Littleton, Massachusetts. They were an early Onshape adopter in the FIRST community and are also a driving force behind the Open Alliance. So for those of you who aren't as ingrained in FIRST, what that means is that during the FRC competition season, all their designs are publicly available. So other robotics teams from around the world can follow along with their progress and borrow some of the really good ideas. Onshape makes it super easy for them to publicly share their CAD models. Across the ocean, over in Saint Louis, France, the DYNAMIS racing team has been using Onshape in their middle school to design cars for the F1 in Schools competition that is rapidly growing in popularity over there. With such a young group of students comprising the team, they've had a lot of success getting students up to speed by using the Learning Center, specifically the Intro to CAD curriculum. If you don't know about our curriculum offerings yet, you are missing out, and you should definitely go give them a look in the Learning Center. Our next team is the Underwater ROV team at the University of Washington in Seattle. So this team is a more recent convert to Onshape, but they are definitely not switching back after it helped them put up their best performance at the 2022 MATE ROV Championship. They've used Onshape in a number of really cool ways, such as designing their own electronics pressure vessel and then testing it in SimScale, one of our partner apps. They're also heavily utilizing Onshape's branching emerging capabilities to make it easy for team members to try out new designs, and when the team votes to keep an idea, they can merge it into their official design branch. Now, quite the opposite of being underwater, the Rockets team from the École de Technologie Supérieure in Quebec is launching their rockets 27,000 feet up into the air. So this team has a pretty cool reason for choosing Onshape as their CAD platform. One of their design leads used Onshape during his professional internship and realized it would be a great fit for the rocketry team back at ETS. So they recently had great success at the 2022 Launch Canada event, and it should be mentioned that they do compete in more than just that one event. So because they compete in multiple different rocketry competitions, they actually use configurations to change the model of the rocket, to change what payload is on board, depending on what competition they're going to next. So now that we've highlighted some excellent teams that are using Onshape from around the world, it's time we take a deep dive into just a few and analyze why they are successful. A great way to improve how you're using Onshape is to take a look at how others are using it and implementing their best practices. So let's do just that. Let's take a deep dive into two highly successful teams that are using Onshape and highlight some practices that every team can learn from. The first team we're going to dive into today is FIRST Robotics Team 1678 Citrus Circuits out of Davis, California. I'm sure that those of you who are familiar with FIRST Robotics will recognize them as one of the most dominant teams of the past 10 years. But for those who are not as familiar with FIRST, Team 1678 is an excellent example of how to inspire students with success both on and off the competition field. So the Citrus circuits were an early adopter of Onshape and made the switch about 5 years ago. When I had the chance to talk with them before Onshape Live, they told me that a huge motivator in this switch was making sure that all their students had equal opportunities to work on the robot design. To put it plainly, their downloaded CAD that they used to use was not running well on their student laptops. They also have currently about 18 students on their design team, and I'm sure you can imagine that keeping everything organized and collaborating effectively can be a challenge with that many people, but they do have an excellent workflow, and we're going to share that with you in just a little bit. And of course, from their performance record, it's clear that it's working for them. They've attended 7 regionals over the past 4 years. They've won them all and also won their division at the first championships twice. Now, of course, I can sit here and tell you that the Citrus circuits love Onshape, but it's better to actually hear it from them. So this first quote is from a design mentor and illustrates a really great point. Because Onshape can run on whatever laptop a student is able to bring to the shop, it's much easier to get new students involved in the design process and get them hooked and keep them interested. From my experience mentoring robotics teams, getting that initial spark can be the hardest part. The student leaders also had great things to say, specifically about the Onshape Learning Center. Having a huge library of high-quality learning resources makes it way easier to learn Onshape and Onshape best practices. One fun quote that I also wanted to share was about Onshape Mobile. The ability to pull up a model on your phone for quick checks when you're in a tight spot or out at the hardware store can really save you some times. So, I did mention earlier that the Citrus circuits had a really good collaboration and organization scheme, so let's take a look at that next. So the process I'm going to describe here is how to design a complex assembly across multiple Onshape documents. This is the process that Team 1678 uses to design their world-class competition robots, but it does work for many other types of end products as well. So we'll start with phase 1. Once the robot is prototyped and the general robot archetype is known, go ahead and create your main document. In this main document, the design mentors and design lead students work together to create the driving sketches. Now, these driving sketches capture as many critical part locations as possible. Think things like bearing holes, pivot points, elevator dimensions, bearing holes on your drivetrain, things like that. When the driving sketches are created in place and the robot is well defined, it's time to start designing each subassembly of the robot, which is phase 2. Of course, in making the driving sketch, you've identified how many subassemblies are going to be in your robot. For this example, we only have 3 because that's what we could fit on the PowerPoint, but you get the point. With each subsystem document created, assign a student leader to manage each of these subsystems. Each student leader now starts working on their assigned subsystem, and this typically gets, 3 to 6 students working simultaneously. Once progress is made and parts are starting to come together well, each subsystem leader can also bring in 1 or 2 junior designers to work with them on their subsystem, which rapidly multiplies the number of students that are now effectively collaborating and contributing to your design. Once the subassemblies are in a good place, we enter phase 3, where the subassemblies are inserted into the assembly of the main document. All of your subassemblies will combine together to make one hopefully completed and working robot. Now, of course, if a student needs more help or wants a design review, it's very simple for everyone to open their subsystem document and discuss areas that can be improved. And of course, as this is going on, these student leads are making versions of their subsystem document, and every time a version is made, you can then go into the main document assembly and update it to reflect those changes. Now, that was a lot of information, but I think this process will probably make more sense if I demo it for everybody. So let's hop into a demo. The best place to start when showing off how to organize a design in multiple documents is a top-level folder. And in this case, it's called Multi-Document Basketball FRC Robot. This top-level folder should be owned by the team's generic account that mentors and design leads can access. That way it's not tied to any one individual, so if someone leaves the team or graduates, they don't take the design with them. For this robot, which is meant to pick up basketballs and then launch them with a catapult, the team decided to break the robot down into 4 distinct sub-assemblies. We got drivetrain, CAD structure, intakes, catapult. The first document at the top, which is the 0 document, is the main assembly. Like I mentioned earlier, this is where the layout and the driving sketches are created and where all of the sub-assemblies are combined to make the final assembly. Below it are the 4 sub-assembly documents that I just went over, and they're numbered usually in the order they're created. I'm personally a fan of making the drivetrain first, so that's document number 1, but of course that's going to depend on what you're actually making with your multi-document design. So let's hop into the 0 document to take a look at how we can start the process with some sketches. As we can see, there's not much going on in this document tab-wise. It's just these 2 tabs. Keeping it to just a couple tabs will help with the load times, so it's definitely a recommendation of ours. We did get dropped right into the Part Studio, and we can see the driving sketches right here. These are pretty simple ones, but it should illustrate the point. I see some excellent teams like 3847, 1678, and 4911 make some really detailed driving sketches that make designing the entire robot off of your sketches very simple. So it helps to create slices of your design, whether it's robot, rocket, ROV. I like to do it from the front, capture some dimensions of the catapult. The one that I think is most important are usually the side slices. Let's hop into one real quick. I also like to use the text feature to communicate what these otherwise random lines would be. Makes it really easy to keep everybody on the same page so everybody understands what is representing different components in these driving sketches. If you want to learn how to get started making sketches like this, there's a course in the Learning Center called Top-Down Design. There's a great intro to this entire concept. So we'll come back to this document when it's time to look at the main assembly, but for now, let's take a look at one of the sub-assemblies to see how these driving sketches actually get used. So this is the drivetrain of the basketball launching robot. It's a pretty simple 8-wheel drive, and the chains are actually tucked inside the tube, hence why I can't see them. But before we could add all the wheels, bearings, motors, all of it together, we needed to model the components that we need to manufacture, which is the aluminum tubes and the gussets. And that was done in this Part Studio right here. In this Part Studio, we can see we've got our feature tree on the left. The very first feature is a derive, so let's check on that. When I open it up, we can see the first thing we derived in were the driving sketches for the size of the drivetrain and the bearing hole location. So once those are imported, it's easy to draw your sketches that they reference these driving sketches. Let's open up the drivetrain tube sketch real quick. And you can see that I actually didn't have to put many dimensions in because everything is coincident to different components of the driving sketches. What this also means is that if I need to update the driving sketch in the 0 document, I can have it parametrically update everything in this document, which is a really cool process. So everything is tied back to these sketches. It creates our one source of truth. Very easy to modify the design from one location. Something else important that I should note is that it's helpful to put a mate connector on the origin. See, I've got one down here, and then tie it to one of the components in the Part Studio so that when you go into the assembly, it's very easy to use that mate connector to tie everything to the origin and fix it in place. Also, to show how version control works with this management scheme, I'm going to make a modification real quick to the bumpers, and then we're going to make a version, and we'll see how that propagates over to the actual design. Let's bring that out just a little bit. And I'm going to change the color just so it's super obvious. And then I'm going to make a version. This will be version 9. Cool. So at this point, Let's say that we've had a team of designers all working hard to design this robot, and we have enough done that it can be combined. So what is this going to look like? I'm going to hop back into the main assembly to show that off. As we can see, the main assembly document has all the subassemblies combined together to make one hopefully functioning robot. I can move the intakes, and I can also move the catapult. Everything's able to move as intended. And because everything is subassemblies, it should only take one mate to tie everything together per subassembly. So I've got that mate connector I mentioned of the drivetrain. That's actually tying to the origin here to lock the drivetrain in place. Then I've got a fasten for the intakes, a fasten for the catapult, fasten for the catching structure. I can also see that my drivetrain has that newer version that I can update to, as indicated by that little blue icon. So if I click on that, I'll go to selective update. I can change this and click update selected, and it's going to think for just a second, and then we're going to be able to see that change I just made reflected. There you go, just like that. That was a quick overview of how this process works. This is absolutely something I suggest testing out with your team to figure out what does and doesn't work for you. Also, if you want to check out this specific model, it's included in Unit 4 of Onshape's Intro to Robotics curriculum. There are some neat details in there that I didn't have time to show, like the use of in-context part studios and editing that can make designing your complex assemblies really slick. So we really like this workflow. I feel that it would work well for a lot of teams, again, regardless of whether you're building a robot or a car or a rocket or whatever mechanical system you're trying to whip up. So if you can follow these three general phases, starting in one document with your sketches, then breaking it into multiple documents, and then recombining at the end, we think you and your team will be in pretty great shape. So thank you to the Citrus Circuits for sharing their workflow with us, and best of luck to them in their upcoming competition. They're actually hitting the competition field this weekend. So Dom, I'm going to toss it over to you for your deep dive.
Yeah, thanks, Drew. That's super interesting and is really a great way to work. Once you figure it out, spend some time doing it, you can be really successful. So I'm going to be talking about Tufts Electric Racing. This is a team at Tufts University that I've been working closely with. They're building a fully electric car for the Formula Hybrid event, and they've been having a lot of success with Onshape. So the team recently switched to Onshape this year, and one of the main reasons is from experience with First. One of their leadership members had actually used Onshape at their first team and saw how impactful it was on their team and thought, why don't we bring this to the electric racing team? And so this year, when they made the switch, they had already been working, over COVID, designing a car in a different tool, and they wanted to be able to use all of that work this year. And so they were able to import their design from last year and keep building off of it, which is definitely really important for a lot of these teams and your team that maybe is considering switching to Onshape, but you don't want to lose your work that you've been working on previously. So when we talked with Tufts Racing, they had a lot of great things to say about Onshape, which we always love to hear. But really what it came down to for them was the just ease of collaboration. They're all able to work on the same documents at the same time with all these subsystems. And it was easy for leadership to keep track of what all the subsystems were doing, which is definitely important as your team gets larger and larger. They also were really impressed when they gave it to new members or members that had never used Onshape before with how easy it was for them to get up and running. They just found the user interface a lot more approachable, which, again, we love to hear that. So like I said, they were trying to import their work from a previous year and they wanted to keep using it. And we kind of came up with this strategy for them to go forward and be successful with that. And I think it's something that a lot of teams will find useful, so I wanted to cover it here. The first step is always gathering your files from your other tool. You can just put them in a folder and you'll be able to import that into Onshape really easily that way. Once you have your files, you'll then want to import them into Onshape. There's a bunch of different options. We'll cover that in a demo in a second. Once you bring it into Onshape, just like what happens when you switch between any CAD tool, some data and information might be a little bit lost. And the key one here is those mates that define the relationships between parts. That doesn't carry over between tools, no matter what tool you switch between. So you'll have to spend a little bit of time resetting those up. But luckily, things all import in the correct orientation. So it's really easy to do that. You can also edit your old parts, which is really cool. So if you have things that maybe you're cutting or welding and, in real life, you would actually change a part, you can do that same thing in Onshape. And of course, you can model your new parts, and we'll show that in a second. So let's go ahead and hop into Onshape for a quick demo of that. So now we're in Onshape. And the first thing I'm going to want to talk about is that first step of really gathering your files and getting ready to import. So here in File Explorer, I've got a couple of files, and one of them is the Tufts Racing Car Assembly Full. So this is their actual file that I was working with them to get uploaded, imported, and use. And so you can see it's a zip file. And if we open it up, you can see it has all the actual individual. Sorry about that. Looks like there's something going on, but let me go ahead and try something else for you. So once you've gathered your files, you'll actually want to go ahead and import them. And that's really easy to do. You can go ahead, click your import button, go ahead and find wherever they are, select them, click open, and then you're presented with a couple different options here. And so I recommend a lot of teams, if you have a lot of documents, go for that split into multiple documents. This will break it down by subassembly, which really is probably what you want to do. And that'll make it easy kind of to just go right into that workflow that Drew was showing. If you're coming from a different tool like SolidWorks, you want to actually click this y-axis up, and then you can click import, and it'll take a second. So it's going to take a second here to upload. Once it uploads, Onshape is going to take a little bit to also then translate it so that you're able to view it. So I've already gone ahead and uploaded one for a demo here, since it could take a second. So you can see this full car, which has like 1,000 parts, has been broken into its different subassemblies that I created earlier. So all the subassemblies are here, and we can take a look at that top level assembly. And so it'll open up, and you can see that a lot of the parts here aren't actually fixed. They are movable. You can see that with this icon on the left. And so this is something that you would want to go ahead and reset up those mates. And that's easy. I'm sure a lot of you have used Onshape before. You can use the group mate up here to group things together that you don't want to move. Say I want the chassis and the seat and all of this. None of that's actually moving. It's bolted together. So you can group it together. And if you have things that move, you'll also want to set those back up. Once you've done that, you'll then be able to start editing and adding new parts. So if you wanted to edit a new part, or edit, an old part, you can actually go ahead, right click on a part, and then go right to it. So I'll switch to this part, and it'll take a second here to load. But you can see maybe this mounting plate for the suspension. We've actually decided we want to use a bigger shock, and we're going to need a larger gap here. I can use these direct editing tools up here, like Move Face, to go ahead, click on it, and actually go ahead and make that gap larger. So I could do that to both of these faces, say that's a better design, and that'll be updated. And like Drew showed a minute ago, using versions is super important. So I'll go ahead, create a version here, and then we can go back to the full car, and we'll see that change reflected with this gap being larger. You can also create new parts using the assembly with in-context modeling. So say we wanted to create a new headrest back here. You can set up this model for in-context modeling. And the way to generally do that is to go ahead and click on the things that you don't need to see in your in-context modeling. So if I'm just concerned about this, I don't really need to see the rest of it. And I actually don't need that anymore. And so you can see there are these posts here that I might be designing around along with the seat. So I'll go ahead and create a new part studio in context. I'll click the origin and we'll hop into this new part studio. And so now you can see we're in the part studio. We have the assembly still here kind of grayed out, and you can actually still highlight and use different parts of this. So for example, if I wanted to create a new headrest, I can go ahead and start sketching on the end of one of these posts. And I can start actually using all of this reference geometry from the assembly, which is really great for designing parts in context with the rest of your assembly. So I'm just going to quickly draw a sketch that might not make a lot of sense here. I'll extrude it. So we went from one type of headrest to this new one. I can click insert and go to assembly, and we'll go right back to the assembly with our new part that was designed in context. So that really lets you use the CAD data that you've had previously. Maybe you actually already manufactured this frame like the Tufts electric racing team had. So it's really great to be able to keep using that really seamlessly, be able to integrate Onshape into your workflow. Cool. Let's go back to the PowerPoint. So like we said, pretty straightforward. Gather your files, import it to Onshape, set up any of those mates that you might have lost. Then you're able to edit the old parts that you had, and you're able to model new parts, which is really everything that a team needs to keep going. Great. I'll hand it back over to Drew to show off some resources.
All right. Let's wrap this thing up by going over some of the resources that we offer that will help your team design the best creation possible. So if you've been around Onshape a while, I'm sure you've heard of the Learning Center, but it really is the best way to get started with Onshape. I specifically make sure that the students that I mentor go through these first two learning pathways on the left, which is CAD Basics and Data Management. The CAD Basics lays out an excellent foundation for how to use Onshape, and the Data Management makes sure that everybody knows how folders, sharing, versions and history, everything like that works. Of course, importing data, like Don mentioned, if you're an FSAE team or a team that wants to use your old CAD data, that one is definitely of interest to you. Onshape also has a huge variety of partner apps that can really help when creating or verifying your designs. So apps like the MKCAD library or 3dfindit.com make it really easy to find and assemble a huge number of common off-the-shelf components, which saves you a ton of time because you don't have to dig around supplier websites for CAD files. And if you're looking to verify your design, apps like SimScale or OnScale Solve will allow you to use your Onshape models for solid mechanics, fluid dynamics, thermal analyses, whatever you may need, depending on what your competition requires. All right. With that, I think it's time for some Q&A.
Yeah, thanks, Drew. So we've got a couple questions coming in, but definitely feel free to add more questions if you have them in that Q&A panel on the right, and we'll try to get to them. So one question we've got is, how do I get my team started if they're interested? And I mean, it's pretty easy to get started. I definitely recommend the first thing you should do is get them to onshape.com/edu, where they can sign up for a free account. It'll take seconds for them to get an activation email, and they'll be able to hop right into Onshape. Once you've done that, it's definitely worth having them go through a couple of those resources that Drew just mentioned, the CAD basics if they've never used CAD before, or intro to Onshape if they've never used Onshape before, but they might have used a different tool. And then I'd really take a second to just talk with your team, figure out how you want to organize things. Onshape with its sharing and collaboration is a little bit different than you might have been used to running your CAD design. So it's definitely worth it for at least the e-board or leaders of your team to think about how you want to organize things and how you want to implement the system that Drew covered. And of course, if you need any help, I definitely recommend any of the university teams. I work with a lot of university teams and higher education teams. So you can also feel free to reach out to me at my email, which is ddamari@ptc.com. So definitely happy to help with teams as well. because sometimes it can be a little bit of a challenge making a change. Let's see, other questions. So here's one. What is the best way to teach my robotics team how to properly design a robot? And I think, Drew, that one's right up your alley.
I feel like that question's for me. All right. So there are a lot of resources that like we at Onshape have actually worked with. So a ton of the members on the PTC education team are, former robotics participants or current, mentors, me included. So we have actually worked really hard on a CAD for robotics curriculum, and it was released earlier this year. And that's in the Onshape Learning Center, and it's got materials for FRC, FTC, and VEX. So regardless of what major robotics competition you're participating in, there is a huge variety of material that is directly targeted towards your specific competition and should really give you some of the best inside tips and tricks on how to design the best robot possible inside of Onshape. There are also a lot of community-driven initiatives that we should shout out. Again, I mentioned it earlier, but the MKCAD library is fantastic and has saved hundreds of FRC teams, hundreds of hours by just having all of their components already inside of Onshape. There's also the FTC parts library put together by FTC Team 2901. Highly recommend checking that out as well if you're participating in FTC. And there are a whole lot more because the robotics community, when it comes to Onshape, they are very passionate. So, yeah.
Cool. Drew, I think I've got another one you can definitely answer.
All right.
If I'm a mentor for a team, but I'm not officially employed by the school, can I still sign up for an Onshape education account?
Yep. The answer we always go with is yes, you absolutely can. So the Onshape education standard accounts, which are free, those are meant for students, educators, and mentors. So even if you're a professional, if you're working with a school or even like a homeschooled group or a community team, you are more than welcome to sign up for the free Onshape education standard accounts at onshape.com/edu. And it is going to ask you for a school website or something like that. You can put the school's website, or you can put your robotics team's website, or your whatever competition you may be participating in. So that was a long way to say yes, you can absolutely have an Onshape account.
Cool. So here's another one, and I can probably take this one. What is the best way to share my team's work with people that haven't used Onshape, like at a competition or a club fair or something like that? So if you haven't seen it already, in Onshape's share permissions, you can turn on something that's called link sharing. And so link sharing lets you give it the URL of the document to anybody. And even if they haven't signed up for an Onshape account, they'll be able to paste that into their browser and see a view only view of your document. So this is really great for if you're at competition or in a design notebook or something like that. Or I've also seen teams create like a QR code with that URL. And then from there, they're able to put it onto a resume or into their, they might create a portfolio of their own work. And so you're able, instead of just, like I was saying earlier, just having a image of something you designed in CAD, you can actually have the link directly to the CAD model. So it's much more interactive for people to see it in a portfolio or something like that. So I definitely recommend turning on link sharing. You can share it with parents, you can share it with professors, even if they haven't used Onshape yet, which is really cool. Cool. Another question here. How many of our team members can we have working in one Onshape document at a time? Drew, you want to take that one?
Sure, you got it. I'll take that question. So answer is as many as you want. Now, for our recommendations, when the document starts to get larger, let's say you're working on a really complex FRC robot, or your, FSAE, card design is getting pretty complex, probably try to keep it to around 5 members at a time that are actively working. Just keep everything, manageable, because it's going to be a lot of tabs and a lot of people doing a lot of work. And that, that process I showed earlier of breaking your design down into multiple documents, that's where it will really shine, because, then it's really easy to have, a huge number of people all working effectively on one design, but it's split up across multiple documents. But just for a little bit of personal experience, I think I've had about 15 people working in a robot document before, and it worked great for us. So yeah.
Yeah, that's awesome. I'm not seeing too many other questions at this time. Drew, got anything else to add, or should we wrap it up?
Let's take a look. Yeah, I think we should just wrap it up.
Great.
All right. So before we close, I'd like to say that, Dom, I, and many members of the PTC education team will be at different student competitions. So if you see us, don't hesitate to come talk to us about Onshape. We love talking about it. Personally, I'm going to be at the Granite State FRC district event this weekend. I'll be at a bunch of New England events, and I will be at the first championship. And, if you want to come see us, come to LiveWorks. That's PTC LiveWorks event is happening May 15th through the 18th. Student teams will be featured in the expo hall and in breakout sessions. And there's also going to be multiple dedicated education sessions. So if you found this presentation interesting, I guarantee that you will enjoy what we will be showing at PTC LiveWorks. So thank you to everyone for attending today. And we hope this session helps your student team succeed with Onshape.